Welcome to Online Learning by Professor Tanujada N. Dati from Electrical Engineering Department, KK Institute of Engineering Education and Research, Nasik. In continuation with the numerical integration methods which we have introduced in the previous presentation, this presentation includes two more methods which are from the set of Newton-Cotes methods. We will learn in this presentation Simpson's 1/3 method and Simpson's 3/8 method, which are respectively called as 3-point and 4-point methods. Earlier, we have studied trapezoidal rule, which for evaluation of integration with single and multiple intervals to improve the result. This method was using 2 points, and so two formulas suggested for trapezoidal rule and multiple interval method are given as I integration equal to h divided by 2 into fa plus fp, which are the function values given at the starting and ending point of the interval. Now this is the normal trapezoidal rule, which is using single interval b minus a as h value. Whereas for improving the accuracy, multiple intervals are suggested where h is calculated, understood as the number of intervals which we want to take between b and a, and so h value can be calculated as b minus a divided by number of steps or intervals which we are taking as h value. The integration formula changes itself to h by 2 into the bracket functions evaluated at the starting point and ending point added together plus summation of all the intermediate function points which are obtained for intermediate data points, which starts from I equal to 1 to n minus 1. Remember, all the data points will be counted from 0 to n. This is one example which we have tried solving. You can try solving this example again as a revision using trapezoidal rule as well as trapezoidal rule used for multiple intervals. Since the time is given from 0 to 3 seconds and the velocity meter per second is given from 0 to 14, we can try calculating understood as starting point as 0 to 3, and we can calculate the integration by using trapezoidal rule as well as trapezoidal rule with multiple points, and we can compare the results as earlier to obtain 21 and 29 by two different methods. Trapezoidal rule with multiple point is considered to be giving better accuracy in comparison with trapezoidal rule with single interval. Now to continue with this, let us understand in real world where do we use these integration formulas or numerical methods which are required to be used for certain applications. Suppose we have to calculate area of an irregular shaped piece of land. What would we do? If it is not of any regular geometrical shape, we find it very difficult to calculate its area. Now suppose we divide this irregular shape by assuming a center line drawn at the center and keep on taking various measurements along the boundaries of this piece of land. It is possible that we can consider these as data points, and using numerical integration method, we can calculate the area of this irregular shaped piece of land by adding all the areas together. Second example is if we are trying to calculate volume of the earth which is removed from a trench or canal which is to be dug, and suppose we have to calculate the number of trips required for transportation to carry the mud away. How would we do this? First we calculate the area and then we multiply it with length to obtain the volume. The length of trench or length of canal can be used for calculation of volume, and then that volume can be subdivided into amount which can be carried by a single transportation vehicle, so that we get how many trips are required and how much would be the cost for that. In real life, integration methods are used for such calculations. And for electrical engineers, we know calculation of RMS value of a sinusoidal quantity, may it be voltage or current. If we try calculating, we can take samples, or we can use the function as sinusoidally varying function or cosine function, and we can calculate the RMS value. For RMS value, we take first area covered under the curve, and then we try calculating average value as the effective value. So, if we have understood these real applications, let us go and try learning few more methods similar to trapezoidal rule, which are also set of Newton Cotes formulas. The next method is Simpson's 1/3 method, which uses 3 points. Now, out of 3 points, if we assume that A is the starting point of the interval and B is the end of the interval which is suggested, we are trying to obtain a third point, which is obviously the midpoint of A and B interval, which is given. But now we have 3 points which are available, and so we can calculate and obtain the value of function at point A, function value at the midpoint, and function value at the end of the interval. So now we have 3 data points, A and f of A, M and f of M, and B and f of B. Using 3 data points, what we are trying to do is, we are trying to fix a polynomial which is a quadratic polynomial, so that we can use function as a0 plus a1x plus a2x square, which approximately looks like this. This is the polynomial which we are trying to fit, whereas actual function could be of this nature. Now we can clearly see that this is the approximation which is shown by p of x, and this is the real function. When we try calculating the area covered by the function and we are approximating it using p of x, there is surely going to be some error, which is the difference between areas which are covered by these two curves, which is obviously seen clearly in the diagram. But to minimize the error, we can adopt some of the methods, and to minimize the difference between these two curves can be taken care of. So for Simpson's 1/3 rule, what we are doing is, using 3 data points as we said, integration value can be calculated as h by 3, where h is the difference between b and a, as we have calculated b minus a, divided by 3 because we are taking 3 data points, and then in the bracket we are adding the functions, which is function at a point, function at b point, and the midpoint is given special weightage, so it is getting multiplied by 4, and this is the function evaluated at the center point. A plus b by 2 is nothing but the midpoint which we have calculated. Now using this, we can see that there is small error which is associated with the formula, but Simpson's 1/3 method can be popularly used as 3-point method as one of the formulas suggested in Newton Cotes family of formulas. Now for reducing the error, we can again try using multiple intervals with more data points using the same formula. Now suppose we are trying to calculate velocity and time is given, and we are trying to estimate the distance travelled in the interval. For solving such problems, the data points will be available in the form of time and velocity, which are the independent and dependent variables, whereas we need to understand that the distance is the integral of velocity. And so when we say that, nobody will say that you use integration formula, but it should be understood that distance is nothing but it is integration of the velocity. So we need to take integration in this range 0 to 3 for the velocity, which can be expressed as v of t, it is a function of time, and its values can be used as from the table. So once we understand this, we know that the formulas which are available at present, you have trapezoidal rule, with single interval, multiple interval and Simpson's 1/3 rule at our understanding, which can be used, and we can try calculating this. Obviously, the answers would vary little bit and we will be able to understand which gives more accurate result. Now, this is the second example. If we are trying to estimate integration of say 1 by x dx in the interval 1 to 3 using Simpson's 1/3 rule, how would we be doing this? H is calculated as b minus a, which is 3 minus 1, which is 2. And then since the function is given instead of data points, we need to obtain the data points by using this function by taking different values of x starting from the first point of the interval, which is a, which is equal to 1. We can evaluate what is the function value, which is 1 by x. This becomes the midpoint. So x takes value of 1, 2, 3 because h value ultimately is 3 minus 1, but we are taking 3 data points, so we are dividing it into 2 intervals. And so corresponding function points are 1, 0.5 and 0.33. Once we get 3 data points, we can put the formula and we can put value of h to be 2 by 3 in the bracket. We can keep on adding 1 plus 0.33 plus 4 times the midpoint, which is 4 times 0.5, and the answer comes to 2.22. Now, to improve the accuracy, as we said, Simpson's 1/3 rule can also be used as a composite Simpson's 1/3 rule, where the number of data points can be increased, and now the formula which is suggested uses the data points which are not only 3, but there will be number of data points which can be obtained. And so h value can be calculated depending on how many steps we have decided to take between the suggested range a and b. So h can be calculated, and h by 3 in the bracket, the formula changes the starting point plus the ending point function value plus 4 times. Now we have to subdivide the points as odd data points and even data points, not for the value but for the number which we are taking. If we call it x of I, when I is odd, we call it odd value. When I is even, we say it is even value. And so we have to give different weights, 4 times and 2 times for odd and even respectively, to complete the formula. Now we can look at this solved example for understanding this. Now suppose we are trying to estimate the same problem which we have solved earlier by using Simpson's 1/3 rule. Now if we try calculating this with 4 strips. Now this 4 strips means we have to take calculation of h as in the range of 3 to 1, we have to take 4 steps. And so value of h changes itself from 2 to 0.5 from the previous example. Accordingly, now we are taking x, y data points we obtained from this given function, starting with x value to be 1. Then it will be incremented by h. So 1 becomes 1.5, 2, 2.5 and 3. So we have got 5 data points with 4 intervals. And accordingly we have calculated the y data points. Once we have this set of data points, we can use the formula which is a composite formula which can be used as y0 plus y4, which is the last value, 4 times y1 and y3 and 2 times y2 to evaluate. Try, check, calculate and see your answer, which can be compared with the previously calculated value. There is one more formula which is called as Simpson's 3/8 rule. As it suggests, to improve the accuracy, we are giving and suggesting different weights for the intermediate value. Simpson's 3/8 rule is actually used for 4 data points. And so it uses the formula 3 by 8h, fx0 plus 3 times fx1, fx2 all added together and the last value. This is quite easy. Its error associated is different than the previous formulas, and we can try solving these examples which are given by using 3/8 rule as well. It is simple formula substitution, and we can compare all the rules which we have studied, trapezoidal rule, Simpson's 1/3 and 3/8 rule, with their associated errors and the basic formulas. These are some practice problems which I have suggested you to